So for the second part of 5.4, we're talking about corollaries. Remember, a corollary is a statement that directly follows a theorem or can be proven by using a theorem. So corollary 5.2 is the corollary to the base angles theorem. If you have a triangle, instead of just with two sides congruent, if it's equilateral, then all three sides of the triangle are congruent, which means all three of the angles opposite the sides are congruent. Or in other words, all the angles are congruent, which means all of the angles are the same measure or equiangular as far as the type of triangle it is. So I have all three sides, AB, AC, and CB congruent in the triangle, then all three of the angles are congruent. And they would actually all measure 60 degrees. 180 divided by 3 gives you each of the measures of the angle, 60 degrees, and it's equiangular. And then the corollary to the base angles theorem, if you have all three angles of a triangle congruent, that means it's equiangular, then all three sides of the triangle are congruent. And then taking a look at a couple of examples here in the diagram for each of the problems, here's what we're given. It says complete each statement and then state which theorem that you used. So if NJ is congruent to NM, you basically want to ignore NL and NK. So maybe even draw the diagram without those segments in it. So here's J, N, and M. But if NJ is congruent to NM, then you use the base angles theorem. Two sides of one triangle are congruent to two sides of a second triangle. Then the angles opposite them have to be congruent. Angle J, or angle NJM, you could also say that, is congruent to angle M, specifically by the base angles theorem. And then for the second example, or problem number 2, it says LM. So I'm going to get rid of this because that information is no longer true. But LM, that segment or that side is congruent to LN. Then you just want to take a look at this triangle. Then angle M is congruent to, instead of just angle N, because there's quite a few different angles that we're talking about for angle N, it'd be angle LNM, again by the base angles theorem. That angle M is congruent to angle LNM, base angles theorem. For example number 3, angle NKM. So here's from N to K to M. This angle right here is congruent to angle NMK, this angle right here. So here's the triangle that you want to take a look at. Again, maybe it's helpful if you redraw that triangle. But if those two angles are congruent, then the sides opposite those angles are congruent. So side MN is congruent to side KN. And then you would specifically be using the converse to the base angles theorem. And number 4 is pretty similar. My diagram's getting pretty messy there. So you can figure out number 4, try that on your own possibly. You might need to kind of back up the video where I didn't have this triangle drawn out to be able to figure out problem number 4.